Welcome back. Today, we're diving straight into exactly how the internet works, how our devices actually talk to each other, and the absolutely critical role protocols play in all of our digital communication. Mastering this invisible architecture, yeah, that's a fundamental stepping stone for literally any cybersecurity professional. So, let's kick off this explainer with a fundamental question. It's one that every aspiring ethical hacker or blue teamer needs to be able to answer without hesitation. What actually happens when you hit send on a message or type a URL into your browser? I mean, it feels like magic, right? But underneath, it's a highly structured, almost mechanical process. Here's our mission briefing for today. We'll be tackling the world's largest network, the rules of communication, the data transmission process, the security perspective, and finally, we'll wrap it up with our Day 19 summary. All right, Section 1, the world's largest network, covering the internet and networking. It's so easy to just think of the internet as this invisible, wireless cloud floating above us. But the reality, it's highly physical. And honestly, that completely blew my mind the first time I learned it. You might be hooked up to your router via Wi-Fi right now, sure. But to communicate globally, your data is traveling through millions of miles of actual fiber optic cables. And these cables are laid deep across the ocean floor, literally wiring our continents together. Crazy, right? So when we actually define the internet, what we're talking about is a massive global network connecting billions of devices all over the world. Basically, it's a giant network of networks. And it's exactly what enables instant communication, online services, and that seamless, real-time sharing of data across the globe. Now, zooming in just a bit from that massive global view, we get to networking. Networking is the localized process of actually connecting all these individual devices, your laptops, smartphones, printers, enterprise servers, so they can share resources and talk to each other efficiently. And that applies whether we're talking about a small local area network in your house or a massive wide area network. Moving on to Section 2, rules of communication, looking at the protocols that govern the web. Here's the thing, just having a physical connection isn't enough. Just because two devices are wired together doesn't magically mean they understand each other. Think of protocols like the languages of the network. Imagine two people trying to have a conversation. If one only speaks English and the other only speaks Japanese, absolutely no meaningful information is getting exchanged, even if they're standing right next to each other. Protocols are those standardized rules that ensure devices actually understand each other and format their data correctly for the exchange. To picture this, think of an IP address as an entire apartment building, and a port as the specific apartment's door number. When data arrives at the building, it needs to know exactly which door to knock on. For example, port 80 is your standard door for regular web traffic, port 22 is for secure shell access, and port 25, that one is dedicated entirely to routing your emails. Let me tell you, knowing these common ports by heart is completely non-negotiable for network security. Let's look at a real-world comparison you definitely encounter every single day, HTTP versus HTTPS. Back in the early days of the web, almost everything was HTTP, which is kind of terrifying to think about now. It operates on port 80 and sends all its data in plain, unencrypted text, meaning if an attacker intercepted it, they could literally just read your passwords right off the wire. No decoding necessary. HTTPS, on the other hand, operates on port 443 and wraps that data in strict SSL or TLS encryption. Understanding this difference between unencrypted communication and secure encrypted tunnels is the absolute bedrock of network defense. Okay, Section 3, data transmission process, or the journey of a packet. So, now that we've got a handle on the physical cables, the devices, and the languages they speak, let's trace the actual step-by-step journey of the data itself. When you send a file or load up a web page, that data isn't just blasted out as one giant continuous chunk. No way. It's broken down into tiny, manageable pieces called packets. These packets are pushed out of your device, they navigate through incredibly complex networks with routers figuring out the absolute fastest path, and finally, they are perfectly reassembled at their destination. And this whole intricate journey, it's governed by a framework known as the TCP/IP model, which breaks the process down into specific layers. The application layer prepares your data. The transport layer, using protocols like TCP, breaks it into those packets and makes sure they're reliable. The internet layer routes them across various networks. And finally, the link layer handles the actual physical transfer over the copper wire, fiber optic cables, or Wi-Fi. It is just a perfectly elegant, invisible assembly line. Let's jump into Section 4, security perspective, looking through the defender's lens. So you might be wondering, why does all of this deeply technical architecture actually matter to you as a future cybersecurity pro? Well, it's because cybersecurity analysts and engineers practically live inside environments and dashboards exactly like this one. They are the ultimate gatekeepers. And here's the reality. You simply cannot secure a perimeter if you don't know how the gates operate. Every single firewall rule, every intrusion detection system, every network tap, they all rely heavily on analyzing the exact protocols and packets we were just talking about. When you're out there defending a network, your core objectives are going to include continuously monitoring the flow of traffic, detecting any manipulated packets or spoofing attempts, analyzing abnormal protocol behaviors, and of course, securing internal systems using robust firewalls and network address translation, or NAT, to keep those private IPs hidden from the outside world. When you actually look at a network traffic analysis dashboard in action, you get this amazing real-time visualization of exactly which ports are active and how much data is flowing through them. By establishing a baseline of what normal looks like for your specific network, say knowing you usually see a ton of port 443 traffic but absolutely zero port 21 FTP traffic, you can instantly spot dangerous anomalies the second they pop up. It really all boils down to this one simple truth. You cannot spot a hacker abusing a network protocol if you don't deeply understand how that protocol is supposed to behave in the first place. You've got to know the rules intimately before you can catch someone breaking them. Finally, Section 5, Day 19 Summary. Mission accomplished. Excellent work today. Let's do a super quick recap. The internet is that fast, global, physical, and logical network. Networking is the localized process of allowing specific devices to actually communicate. And protocols? Those are the strict rules and languages that make all of that communication coherent and possible. Together, these three pillars form the absolute bedrock of our digital world. By truly mastering this invisible architecture, from the submarine fiber optic cables all the way up to those application layer protocols, you are building the rock-solid foundation required for any advanced cybersecurity career. You aren't just learning how to use computers anymore, you're literally learning how they think and speak. I want to leave you with one final thought to really ponder before our next explainer. Now that you know the exact route a packet takes and how easily it can be read if it's unencrypted, how would you go about stopping an attacker who is silently tapped into the wire and is just listening to your traffic? Think on that, and I'll catch you in the next one.